Welcome everyone to today's presentation by Yugabyte and DZone, Building the Intelligent Data Layer for AI, Architecting Scalable GenAI Apps with YugabyteDB and AWS. Whether you're modernizing your data layer or building GenAI applications from scratch, this session will arm you with best practices, real-world strategies, and future-proof architecture patterns. My name is Faith, and I will be your host today. And we're especially excited to be joined by Ame Banarsi, Field CTO and VP of Solutions Engineering, and Carl Wow, Partner Solution Architect, AWS. It's great to have you both.
Thank you, Faith. Carl, would you like to introduce yourselves to our audience?
Sure, thank you. I'm Carl. Nice to meet you all. I'm Partner Solution Architect from AWS. I joined AWS for 3 years. I help partners speed up the innovation with latest cloud technology on AWS. Before that, I'm a principal software engineer, data engineer, architect, hands-on developing for 18 years. Architecture and build and migrate plenty of systems on the cloud. Nice to meet you all here.
Thank you, Carl. Hello, everyone. I'm Ame Banarsi, and I'm the Field CTO and VP of Data Solutions Engineering here at Yugabyte. And I've been with Yugabyte for 6 years, helping our users and customers with modernizing their distributed mission-critical applications with YugabyteDB. And previously, I used to work in the cloud-native part of the industry with Pivotal, and before that in financial services. So I've been focused on solutions architecture for a decade and a half now. And it's my pleasure to have Carl as our guest expert here from Amazon Web Services for this webinar today. So with that, I'll quickly go over today's agenda. When Carl and I were putting together this webinar, we thought, let's make it very real world, insight focused for our users and the audience here today. So what we're going to do is give you a quick overview of the state of GenAI applications. Then Carl is going to deep dive into what does Amazon Web Services offer to users to build their own net new GenAI applications, or in some cases, modernize their existing applications to have more GenAI style features on it. Then I'm going to introduce you the core YugabyteDB and our vector store capabilities. This is very important because we are a scalable, resilient database which supports these set of real-world use cases. And with that, we actually have a very exciting demo for you where we take some of the real-world data and build a net entire pipeline with a real-world use case and an architecture behind it as well. And at the end of the session today, you'll get access to the demo as well as the GitHub code, fully open source. And at the end, we'll take some questions from the audience, but more importantly, we're going to wrap up with how Amazon Yugabyte collaborates together to solve some of those hard challenges in the data industry and help you create this modern, scalable architecture focused on vector use cases today. So with that, I'll quickly talk about the state of GenAI adoption. As you can see, starting, I would say, last 3 years, the industry has been shifting a lot, adopting these generative AI solutions. And I would say the pivotal point for this was when the first version of ChatGPT came out. Everyone started using it because the data and access to LLMs was democratized at this point. So if you see over the last few years, generative AI itself has been reshaping the entire software industry. Take a look at what you do day to day. If you're using Salesforce, it's powered by live AI agents. If you're using Zendesk, your life is very simple to find a root cause analysis and things like that, because all the data can generate quick insights, whichever domain you work on, whether you're a software developer, an architect, in sales, in marketing. Ability to have co-pilots and rigorous document searches has helped improve productivity tremendously. So I quote here that, one of the research items from IDC is that by 60% of the net new applications will have GenAI capabilities by 2026. But what's more important is that these enterprises have to work with their own data. They cannot take the public data sets coming from external sources like ChatGPT and others. So this is where both Carl and I will be focusing our entire session today on a concept in the industry called retrieval augmented generation, or a short form is RAG, which helps you ground your LLMs to eliminate any hallucinations and focus on your own domain and the data itself. So that way you can build the trust with your end users still making sure that you're able to meet their privacy concerns and any domicile or data related issues as well. Now, if you narrow down your focus on the database part of it, we all know that LLMs, the founding definition of LLMs and the principles as the research began about a decade ago, is that they are purely statistical models. They're not deterministic. So the fact is that if you have a private repository of data, but you still want to leverage the power of LLM when it comes to advanced reasoning, deep research, and making sure that it's able to provide that finesse of an answer to the end user, as opposed to just giving a query with the raw data, we want to make sure that vector databases are able to provide that ability to the users. And as we have seen from this research from DB Trends last year, there is a 4x increase in production use cases leveraging vector databases itself. And this is predominantly happening because folks are now moving from old school legacy data lakes or data warehousing solutions to more real-time distributed RAG layers, where the ability of real-time searches combined with your own protected data as well as external data sources combination helps you generate a very accurate answers for your users. So today we're going to give you that blueprint, basically how to create this high availability and scalable architecture to support your mission critical applications. With that, I'm going to hand it to Carl to give us a quick overview of everything that Amazon does in this GenAI space.
Sure. Thank you. I mean, like a GenAI is everywhere today. Like on AWS, we provide like a plenty of tools to help our customer to speed up their innovation on GenAI. Like on AWS, it's across different layers of tools to help on that. The first layer is the console layer. We have Amazon Q. For example, you can use Amazon Q for developers. If you configure that from your console, it will help you your day-to-day development work there. And on the AWS Bedrock framework, it's a managed service to help you to manage and to use your LM model. And in our RAG demo, we will mainly focus and use Amazon Bedrock for our use case. And for Amazon SageMaker, it will help you to train your data, to train your model, and to manage your model as well. And also AWS provide a different type of like a GenAI optimized service and EC2 instance hardware to help you with your GenAI journey. Yeah, next slide. We will focus to use Amazon Bedrock to help our demo and to help our RAG system overall architecture today. And on the AWS Bedrock, it's a managed service. It's a framework to help you to manage your model. So you can choose a large set of models from the framework. You can choose like a different models for different use case, different purpose, different price, and you have the flexibility to choose all of them. And also another things, it's great about Bedrock. It will bring the security of your data, and we will show that in our RAG demo and overall architecture later as well. Next slide. Here is the large list of the large language model we supported on Amazon Bedrock right now. And you can see there's like a industry leading large language model there, listed there. We have Amazon owned like a model there, Titan, Nova, and we have like a Meta related model. And we also have like a Anthropic models there as well. And even like a few weeks ago, it's very hot, a DeepSeek model we have supported on Bedrock as well. So like a Bedrock is a framework to help you manage and use your model. So once there's a new model, I can foresee there's like after half a year, a few months or weeks, there's new model coming. And soon, like a Bedrock will support that. And then you can use that from our framework without any code changes there. And I want to emphasize our AWS Nova model. So this Nova model, we have Nova Micro, Nova Lite, Nova Pro, and Nova Premium as our understanding models. In our RAG demo, we use Amazon Nova Pro. It helps us to do the LLM task and help us on the chatbot task. And we have the Titan model to help our embedding task. And we have like a in a Nova scenario, we have like a canvas and a real model. We are not use them today, but they will used to generate the image and help us to generate the video as well. Next slide.
Thanks, Carl. I think next time when we meet, we'll definitely love to leverage the canvas and real models and show some more excitement to our users. So folks, again, as Carl mentioned, Amazon provides a wide variety of services to build your own mission-critical, very creative applications using generative AI solutions. So I'll take a few minutes and walk you through what does Yugabyte really do in the Gen AI space, right? As you all know, YugabyteDB is a distributed SQL database. And we have basically built it with the first principles that any user or an architect, while building their applications, should not be worried about scalability or resiliency aspect of the database. They should rely on YugabyteDB because fundamentally, we have designed it inside the database architecture itself and still making sure that you're able to meet geo-distribution, that is end users' data residency and compliance requirements. And the way we do this is by offering this net new database with two of the most popular APIs on the planet. One is a fully compatible PostgreSQL API, for which we work with the industry and we take the entire upper half of the query layer of Postgres and we offer it in a distributed way to our users. And the second thing is, if you have that high velocity, high throughput, low latency style requirement where key value API is sufficient, we offer you a Cassandra API, Cassandra-inspired API as well in there. But the best part about this entire solution from Yugabyte is that it's completely open source and it's extremely cost efficient because now you can deploy it on any hardware you would like. So for today's demo, obviously we are deploying it on EC2s and ECS on Amazon Web Services, but we have plenty of users who are deploying it on other public clouds as well as private clouds or any flavor of Kubernetes as well. Whether it's bare metal, container orchestration, or virtual machines, you get the same exact experience with Yugabyte. So you really don't have to compromise on any cost or performance. Now with that, YugabyteDB started in 2016 with the first and foremost mission that we want to solve for some of the hardest problems in the relational transactional database industry. And that's why we chose Postgres as the de facto way to go and help our users modernize their existing applications and bring in more cloud native characteristics to their application without having to sacrifice performance or latency at any point. And we also wanted to make sure everything is enterprise grade by default. That is, out of the box, you get observability, replication built into the system, as well as very enterprise grade security with that. And lastly, the entire product is offered as a service. You can go to cloud.yugabyte.com, as we are using in the demo today, or you can have the same software deployed on your own Amazon VPCs or your own private clouds, and you get the same exact experience for your developers and architects by offering it as a fully managed service. So that's the power of cloud native architecture that we have tapped into with Yugabyte. And real quick, our architecture looks something like this. On the lower half, our database is a distributed key to a document store, which basically takes care of auto-sharding, rebalancing, and resharding of data with an ACID-compliant distributed layer or transactional layer. And we leverage Raft as a consensus protocol with that. And then on the upper half, we have pluggable API layers. So we have our Postgres API, we call it YSQL. We have our Cassandra API, we call it YCQL. And very soon you will see a bunch of new APIs coming in here because we have that pluggable API extensible model as well. So for today's talk, we're going to be focusing on our YSQL API, which is Postgres compatible. And the best part about Postgres compatibility is that you can leverage the goodness of Postgres and the community for with the ease of use without having to redo any or re-engineer any features inside Yugabyte. So that's why for the last 2 years or so, we collaborated with Postgres community to take Postgres vector library, or as it's called pgvector, and put it on top of Yugabyte through our Postgres API and offer the entire community and the world a distributed, resilient vector search on top of Yugabyte. So as you can see, this is pretty involved. I mean, we had to make sure that everything works correctly and it's also seamless for the end user to leverage it. So it has all the goodness from our database itself, being ACID compliant, transactional, with PostgreSQL compatibility, but now offering a scalable and an extensible vector-based solution, wherein you can actually have resilience requirements where you can lose an entire cloud region or an availability zone, depending on your insurance coverage, without having any downtime to your end user or a bad experience for the end user as well. So that's what the focus is with Yugabyte's vector indexing itself. And just like any other vector store, you can do a lot with Yugabyte. You can essentially create these tables with vector columns. You can create different indexing styles. You can load vector data. And the best part is that it's scalable. So you can elastically scale for your use case and shrink down the cluster when you don't really need. And the best part here is that Yugabyte has worked with some of the topmost researchers and academia to take hierarchical navigable small worlds as one of the best algorithms to support this indexing and search functions as well. And more about that we'll talk in the demo later today. Now, this is a perfect segue into like what Carl mentioned in terms of everything that Amazon offers and what I talked about in terms of all the good capabilities for the end users from Yugabyte's perspective. How do you put it together? And this is why we thought we'll show you that real world application. And the domain we chose for this was global tariff data analysis. Now, as a user, you must be reading a lot of media and news every day. And as you can imagine, it's very hard to keep up with global tariff. Almost every other day, there are new news with retaliatory tariffs and new tariffs that are being applied. And it's hard to predict what is really going on. And with that, the social media sentiments also add a lot more confusion for the end user. So as a user, you always feel very overwhelming with reading the news. And at times, you kind of give up on that, right? So before we go into the demo, we wanted to show you what does it mean to build for an app for such a domain, right? Now, in this case, we have an idea for an app. I'm sure there are a bunch of applications on your mobile phone or on the web which can help you analyze this data. But what we wanted to show our users today is if you had to build this application from scratch, what steps would you do? And it basically comes down to these 6 steps, right? We're going to be focusing on step number 1 and 2 as part of our demo today. That is, how do you prepare the knowledge base? How do you organize all the data? How do you take the benefits of Yugabyte and Amazon Web Services GenAI features to go build this scalable knowledge base and then create indexes on top of it and then serve the user's needs? But if you want to extend this concept, and you'll see this in the subsequent webinars, you can actually build model context protocol servers, advertise those capabilities, configure a whole bunch of clients, and create agent-to-agent applications, which would take the same set of data and the blueprint and make it much more scalable and, in cases, resilient enough so that it can serve multiple other applications as well. So this is your core blueprint as and when it comes to creating these vector applications and GenAI applications in the industry. As I said, we're going to be focusing on the first 2 steps. So let's start with this. As Carl and I mentioned, this is a demo which we take pride because we have created from scratch. But the important point here is that as a user, global tariff analysis is actually very challenging. So you have think tanks of the world, whether it is USITC or some of the best schools in the world like Yale and Wharton, publishing this research of like, this is what the tariff analysis looks like as of today. These are the set of documents. And obviously you have banks like DBS and JB Morgan adding to it. But you really need to be a hardcore economist to really understand and put it together in your head and make most insightful decisions based on that. Now, as a normal user who's in technology industry, it becomes very tedious and time consuming to do this. So The de facto answer is, let me go to Google search or ChatGPT and see what the news is. And it gets very confusing because there are mixed sentiments with that news and sometimes hallucinated AI content. So our goal for this demo today is to leverage Yugabyte AWS to build this RAG application so that you can provide accurate, context-rich answers to our users, and at the same time, take this data from the repositories that are coming from all these think tanks of the world, and make sure that your LLMs are only answering from that data set, henceforth eliminating hallucinations completely. So at the end of today's webinar, what you're going to be getting is basically a blueprint for building these GenAI applications, which are focused on accuracy, domain privacy, scalability, and resilience. And you can pick and choose the LLMs, as Carl mentioned, depending on your use case and volume of data or your cost budget. You can change the LLMs easily without any issues with Amazon and Yugabyte. With that, this is a quick workflow of what we're going to be seeing today. We have the global tariffs documents, as I mentioned, kept in a private repository. Now, step one is taking these documents and embedding them. And this is where the power of Amazon's in-house model, Amazon Titan, comes in. That is, we leverage Titan embedding model to create these embeddings and store those embeddings from vector standpoint into vector indexes inside Yugabyte. Now, Yugabyte becomes a scalable, resilient vector store in this case. And the best part is that we figured that if you want to add for more lower latency and high throughput, you can actually store the chunks of those documents inside Yugabyte itself, henceforth eliminating any latency from external reading. If at all you need to go back to your data. So that's the best part here. It's already designed for very low latency access. And now, in terms of the query, let's say a user like me starts asking questions for these documents. My question itself will be encoded with the same encode embedding model. It will be routed to Yugabyte for doing that quick similarity search. And the best part is the similarity search now goes across all the thousands of documents that we have uploaded, not just one or two documents that are coming in every day. So now you can get more contextual answers from these use cases without having to worry about reading all the documents and becoming an economist in point. So as and when the user sends the query, it's embedded in the same way. The vector search string would go to Yugabyte, will perform those similar queries to find the similar documents, and then we send it to Amazon's Nova LLM. And in this case, we use an Amazon Nova Pro to finesse the answer from our documents with the relevant context and text, and then send the response back to the user. Now, this way, we make sure that there are no hallucinations in the entire process, and only the queries served by these documents will be served as well. The entire solution here is deployed on Amazon Bedrock. So we leverage Yugabyte's fully managed cloud, which is also deployed on Amazon Web Services as a fully managed vector store. And the entire application is deployed on Amazon Bedrock because it's extremely seamless for a user to add new features without having to go through building the entire application yet again. With that, let's take a look at what really happens in real life. And just for our users to see what are the complexities in these documents, I picked up one of the document here, which was published by US ITC recently. And as you can see, it's a 1,500-page long PDF with all the tariff data built into it. Now, as I said, you have to be a strong economist to makes most sense of this kind of information. But the part is that this information keeps updating every day. So you really need to build your own LLM inside your head. And that's what we are offering you. You don't have to do that at all. You just have to focus on getting the right documents, uploading it in your repository here, and you can start asking the questions, just like I'm going to do here. So let's say this is the app that we have built. As we said, this app is deployed using Amazon Bedrock as a framework behind the scenes. The app itself is running on Amazon's ECS, which allows you to run containerized applications at scale. At the first instinct, let's take some of the questions that we have here, and let's say we start asking the questions right away. So let's say I ask a question like, which US industry sectors have benefited or suffered the most from this tariff change? As soon as I click on this, I'll see that here, you'll see that this question has been asked. we took that information or the question from the user, we went through that flow of creating the embeddings for that, and then we sent that to Amazon's Nova Pro model, and we got the response back from one of the documents that we had uploaded with a very concise, summarized way. So if you can see, the response from this Nova model and the data stored in Yugabyte now says that manufacturing industries may suffer, but there are certain beneficiaries there. But across the board, agriculture, technology, retail, and automotive, there are pros and cons with the new tariffs coming in. Imagine you had to find this answer in a 1,500-page documents in few minutes. It is very hard for even the best economists of the world to do that. And that's the power of this architecture now, right? Now let's try one more thing. Let's assume that we go and upload a document for this, which it has never seen. I'm going to take a document from this morning's media report from Bloomberg. I just basically converted a PDF of it, and I'm going to put it here related to tariffs. I went and uploaded it. And let's say I ask it very generic question. Let's say based on this everything going on in the world, how expensive will Apple iPhone become based on the recent tariffs? Just to give you folks a context, it's May 19th today, and a lot of things have changed in terms of how to build an iPhone in general. So if you click on this, it's basically going to detect that a new PDF has been detected. That means a new report has been detected. It's going to sample and generate those embeddings quickly. It's going to go and store that inside Yugabyte. And then the question that I asked right here, here, it's going to embed it the same way and then give it to Yugabyte PDFs and come back with this as well. So as you can see, it says that Apple's iPhone tariff impact will be, based on what the document has, while the exact rates are not specified, it can basically have something like 10 to 15% increase in various goods. Now, the reason it's basically reasoning this way is that we don't have accurate answers uploaded. So it's basically leveraging the content from our domain of repositories of data and then creating this answer for you without any hallucinations. That's the most important aspect of it. Because if you go and Google this, you'll get variety of 10 different answers and you won't know which answers to rely on as well. With that, this being the demo, as I mentioned before, this is fully open source, so you folks can get access to it right after this webinar today. And as you can see, in the step when I uploaded the document, we leverage a library called LangChain, which basically took that document I uploaded from Bloomberg. Using the unstructured library, it basically went and parsed it at scale, gave it to Amazon Titan, which is hosted on Amazon Bedrock, created those embeddings inside Yugabyte. And then in step 2, when I asked questions, it went through this flow. That is, the apps that are deployed on Amazon ECS now went to Amazon Titan for embedding, as and when I asked the questions, performed the similarity search, found the relevant contextual data from Yugabyte, gave the raw data, the exact raw data from various different documents to Amazon Nova Pro. Amazon Nova Pro took care of finessing that response, as you could see it from 2 questions that I asked, and then gave the answer back to the end user. So in all, this entire process happens in maybe less than a second. So it's usually in hundreds of milliseconds that the entire flow goes through, and we're running it on a decent cluster. So as and when you add scale and volume, it will just keep getting better as and when we keep training the models. With that, I'm going to hand it to Carl again, because now let's understand what really happened with that Amazon Nova Pro behind the scenes.
Cool. Thank you, Ami. That's a really great demo. Like the demo show us Amazon Nova is a very clever brain, but the Yugabyte's vector search ability with Titan embeddings, it brings the latest knowledge to the clever brain. With this happen, it can always answer your latest questions, give you analytics on latest data. So that's very great. And I want to talk about the model we are using, Amazon Nova. We are using the Nova Pro. So we have other model as well. Nova Micro is just text models. It will only respond with your text source. And for Nova Lite and Nova Pro, it is multimodal, so it can respond to your image multimodal source as well. And for Nova Canvas and Nova Real, we didn't use that in our RAG demo, but it's a very good model to generate the image and generate the video. Next slide. And this is comparison from Nova Pro with other industry leading models. It has very good performance and have very good cost efficient as well. So I think Amazon Nova will help you on your GenAI applications. Yeah.
Yeah. So Carl, this is I can add it from my own when we were going through this architecture as well, right? We tried a lot of different models. I mean, as you can see, but the ones listed here, the best part about Nova was that first of all, ease of access. It literally took one line of code change to know the model ID and put it in the Amazon Bedrock code that we have been deploying, and just go and try out everything without any issues. So that was the best part. But the bigger part was it actually performed much better in terms of the actual responses to the end user compared to some of these models that you see behind the scenes as well. So folks here on the audience of the webinar, I would highly recommend that you go and try this out yourselves and see how good Amazon has done in terms of their Nova understanding models itself. With that, we'll quickly take a few questions here before wrapping up the webinar.
Awesome. Thanks so much for the presentation and the demo, Ame and Carl. And so looking at some of the questions that we have for today, the first question is, what are the design considerations when moving a RAG app from the kind of just playing around phase into full production?
I can take this question. Like from AWS service, like Bedrock, it's a managed service. For ECS, it can support your scaling. So I would say like from our demo, it's already like production ready. Like it can scale, it can help you, and also Bedrock is a security framework to use to invoke your models. So it's already production ready. Yeah.
Awesome. And so with that, is the content processed by Amazon Bedrock something that you can move outside the AWS region where somebody's using Amazon Bedrock?
I think I can take this one as well. Like a lot of customers, they have concerns about their data. I would say like security is the top thing we think in AWS or all the AWS service. Like for Bedrock, like your content, your data will never leave the region, and our model will never use your data to train the model. So you can consider all related stuff live in the same region, in your own region, and the data is security as well. Yeah.
Thanks, Carl. Governance is definitely so important at this time. And then okay, and so we have another question. How does this type of RAG architecture impact high availability? And also, how can you build this with HA in mind?
That's a great question. I can take it from the HA perspective. So as you can see here, this is our entire end-to-end flow of the architecture that we presented today. Every single component of this is actually highly available and scalable. But I'll focus on the most important part here, which is the data repository itself, right? So as I mentioned previously in the slides here, that Yugabyte by de facto is a distributed SQL database. That means whenever you load data in Yugabyte, we're already creating replication of that data so that if at all you lose one of the fault domains, as we call it, your users have no data loss guaranteed, which means that you need odd number of failure domains to create this cluster of Yugabyte. In our demo today, we are using replication factor 3 and running it as a single region multi-AZ on top of Amazon Web Services, which means that if at all one of the AZs from Amazon is down for any means, let's say because we misconfigured a global load balancer on our end, or let's say one of the VMs had any issues, there will be absolutely no downtime or performance degradation to the end customer who's using this kind of architecture on a demo. So it's always built with high availability in mind. The other thing that I'd like to mention is that when we were working with pgvector and bringing that to Yugabyte, we also ensured that the vector data itself follows the exact same characteristics from Yugabyte's architecture by making sure the vector data itself is resilient, resharded, and rebalanced automatically, and it's highly available at any point in time. And that's the best part about leveraging Amazon Web Services, things like ECS and Bedrock, or even their highly available models. And at the same time, Yugabyte has the core distributed vector search as part of it.
Wow, that's an incredibly reliable service, it sounds like. Okay, it looks like we have time for one more question. And so, when does a multimodal DB make sense versus what we might call a boutique vector DB?
Oh, that's a great question. It's actually a perfect segue into one of the things we wanted to end our conversation with today. But I'll take the highest level first. As a user, you always have options to go with a very specified standalone database, which is serving vector traffic today. And there are a lot of popular ones out in the industry, starting with Milvus, Pinecones, VV8, and others, right? And if your use case only focuses on pure vector and doesn't have anything to do with your relational data components or key value components, and you basically want to service something to the user without having to worry about security aspect, resilience aspect, it's a perfectly fine option to go with one of those. But if you want to leverage the goodness of a relational database and using Postgres, offering that rich set of libraries, not just with vector, but everything else that goes on in a core data architecture, I would say that there are much more advantageous ways to take something like Yugabyte, which is distributed and scalable, and offering vector as one of the things as part of it. And this is where, when Carla and I were putting together the use cases, we thought that even though our first demo would only focus on retrieval augmented generation, or as the industry likes to call it, contextual data retrieval, we can do several other use cases with it. But that's the benefit you get from like having a multimodal API kind of a store with Yugabyte as an example, as opposed to going for a specific API store from others in the industry.
Awesome. So it's secure, it's reliable, and multiple uses. That is what the people like to hear. Okay. It looks like we're all out of questions and time for today, but don't worry. If you weren't able to get your questions in, someone will reach out to you after the event. But now that we're in the end, turning it back to Ame and Carl, where can we go to learn more about Yugabyte and all of the wonderful work you're doing?
Absolutely, Faith. So as I mentioned, right, the industry is evolving at such a rapid pace. This is one of the first things that we came together with contextual data retrieval, right? But the buck doesn't stop here. We can actually go and do more vector search at scale. Carl was talking about that when he was going through some of the Nova models as well. You can actually leverage a similar architecture to serve your users with much more personalized recommendations. You can see a lot of deal websites doing this nowadays. And that's basically the power of Amazon SageMaker to go and fine tune your models and do it at scale, which is a perfect thing. And this is where both Carl and I had interest in, like, leveraging newer models from Amazon, which can do reels and images as well. So you can actually do content generation and management with it easily with a very similar architecture. And you can keep extending these use cases. You can actually focus on building an enterprise knowledge base. You could focus it on doing more fraud analytics as well, like fraud detection and risk analysis, making sure that you are able to catch any fraudulent activity way before it happens. And lastly, you can actually build a very smart AI-powered customer support with the AI agents, as we had walked through in our workflow as well. So it's world full of possibilities here with generative AI solutions, and with Yugabyte and Amazon combined powers, you can actually do a lot more things with it as well. So with that, what we wanted to leave our users with is, if you're curious about learning more about Amazon Web Services, especially Bedrock, there's a fantastic knowledge base out here with Amazon's best practices that you can leverage and start working on it right away. Amazon offers a very lucrative trial period to go and try out all these solutions, and it's easy to consume as well. If you're ready to try the entire demo yourselves, you can actually go and try out our fully managed cloud. And as part of this webinar, we'll also give you the GitHub repo for our application as well for global tariff data analysis. And you can go try it from Yugabyte and Amazon together. And if you're curious to learn more about vector search and best practices in general, you can click on this link number 3, which gives you very good insights into RAG architectures and GenAI apps itself. So with that, it was a wonderful conversation. Carl, any closing thoughts from you?
I think you cover all of them. It's great, like Yugabytes from vector search and AWS Bedrock from the large language model will help you with your GenAI innovation.
Thank you, Carl. It was nice seeing you here today. Thank you.
Yes, these are fantastic resources and speaks to so many things that we're all thinking about right now. Therefore, we hope you found this session valuable and informative. And if you have any further questions or if you would like more information, please don't hesitate to reach out to Ame and Carl and the team at DZone. Once again, thanks for joining Yugabyte and DZone today and have a great rest of your day.